answer is yes. Bed bugs make radioactive gas. The bugs in the bed, coal bed, will transform things, and you get a radioactive gas in both the methane and the CO2. There I am taking some samples. The fruitland formations up in northwestern New Mexico. And there's a result. Lo and behold, there's carbon-14 in fossil coal and in the methane that comes out of the reduction of coal. Once again, I've got another data point that sort of sticks out like a sore thumb, and that's explainable. But notice that it's a pretty good close grouping. Methane being lower than the CO2. But there we are, down there around 0.5 for a mean value for the methane, and around 1.48 for the CO2. It's still thousands of years old as opposed to millions. Oh, okay. Well, what about if you have a very deep well? Does that imply deep time? Well, let's see. I went and took samples out of the Ellenberger Formation. The Ellenberger Formation is, on this depiction, is right in here. Here's the Ellenberger. All right? And notice the depth. That's 3 miles deep. Say, well, you know, it's way down there. It's got to be very, very old. And there couldn't possibly be any carbon-14 in that stuff. Well, there's where the fields are. You notice just above and to the left, you see that little wiggly line going up to the Texas-New Mexico state line. That's the Pecos River. And there's what it looks like. The wells were predominantly up on the top, a few down in the valley. And the results are that fossil gas has carbon-14. What a surprise. And it's a pretty nice grouping there. Once again, the CO2 tends to shift off to the right. But notice that the mean value is around 0.3, which was slightly above that, which was John Baumgartner found for coal. And the mean value for the CO2 was just slightly above that. That was pretty nice information. I really enjoyed that. I sent it to a old earther friend of mine who's sampled some similar wells. He says, I can't believe it. There's the data, but there's got to be an explanation for it. He went searching for the explanation, never could find it. Other than what you see is what you get. Well, all CO2 gas wells, coal bed methane wells, and natural gas wells also had noble gases present. And so what's the connection? Well, back in '61, they found anomalous amounts of noble gases in our New Mexico CO2 wells. And the values were unexpectedly greater than air values. It didn't fit the evolutionary model. And xenon was particularly that way, and there was a whole bunch of investigations that have come about over the 4 decades, now 5. So why was xenon of interest? Well, xenon 129 compared to xenon 130, xenon 130 being a stable isotope, was 10% greater than the air value being 6.48. And so they presume that it must have come from the decay of iodine 129, which has a half-life of 15.7 million years, or plutonium with a half-life of 82 million years. Therefore, if you're an evolutionist, it makes sense that the stuff is very old and came out of the mantle. Remember the first part of the talk? The atmosphere came from the mantle. That's the evolutionary hypothesis. Well, let's see. we have some work in the literature that sampled xenon. Caffey and company did it in 1999. They looked at 4 different wells, just one well per field. And there's New Mexico, Colorado, Colorado again, and then in South Australia. I did contact some people in Australia and asked them to go sample the well. They weren't interested. But the other 3, I sampled myself. So I thought, let's see here. So in another paper, why Holland and Ballantyne, they did extensive analysis in 3 of the fields that I had done work in. So I looked at all of that. I thought, they took all their values and came up with mean value for each field. And I thought, gee whiz, that looks familiar, that trend, to what I found in my own analysis of CO2 and carbon-14. And so I compared them. I thought, it looks like might be a correlation there. I thought, well, let's see. Let's go a little further. And there's a possible correlation. What's interesting is that you see a little blue square box up there, a little term there says M1 value 1.15691. And this is a constant in the equation for the curve fit. When I did some analysis from a different direction, I came up with a curve fit constant of 0.15964 from a completely different direction. I thought, is this serendipity or am I onto something? So I think I'm onto something. So, well, it's an interesting correlation. But then you look at the data and you say, is what the evolutionists say is the anomalous become ubiquitous. And it seems like there's more of this xenon down there deep than what they would say. Remember that the air value is 6.48. So, come up with a theory, since xenon-129 is cosmogenic meaning that it can be related to the air, xenon being a constituent of air, that it can interact with cosmic rays and it produces xenon-129. At the time of the flood, there were dramatic changes in the Earth's magnetic field. Dr. Humphreys has done work on that. Thus, there would be a drop in the xenon-129 in the atmosphere towards its current value. In other words, if the drop in the magnetic intensity allows more cosmic rays to interact with the atmosphere, a constituent of the atmosphere being xenon-129, and its value drops. Okay, and it's converted to iodine-129. All right. So where's the iodine-129? It goes in the ocean. What do we find in the ocean? Iodine-129 is down at the bottom of the ocean. Oh, well, how about that? Does that fit? Well, yes, it does. So the conclusion then is that the amount of carbon-14 and xenon-129 appears to track each other based on limited data. The xenon data was, according to the evolutionists, unexpectedly greater than that for air, but it makes sense when it's examined in light of the flood and an Earth created in equilibrium. Now, that's an assumption, but I base that on the nature and character of God as revealed in the Scripture. That He created a perfect Earth, and things should be, as a scientist, you like equilibrium. Okay? You like equilibrium in your life, too, don't you? And so here we are, so that I would say that the xenon ratio would be around 7. Okay? And then, boom, here comes all this cosmic energy, and it's reduced in the atmosphere. The xenon is converted to iodine-129, that goes in the ocean. Okay, well, there's our explanation for what we find now. And so you say, you put all that together, and you end up with our current atmosphere making sense that is very close to that of the original atmosphere. And that fits a creation model. But that's a radically different view from that of the evolutionist. So what else is new? So I have two isotopes that I believe point to a young Earth. Thank you. Okay, now that I've dazzled you with all the footwork and analysis, questions? Okay, the question is anybody tried to refute what I've done? Have they tried to refute what John Baumgartner has done in coal and diamonds and so forth? There was one attempt, and it was basically along the line of your question. And that is, well, it was generated by the nitrogen down in the mines and so forth. And the answer was, they went and did the analysis, and the residual radiation levels are far too low to make the conversion to any significant amount. Like my friend of mine, he recognizes the work, but he just looks the other way. I even graciously offered to see, would you like to co-author with me? Since he's done work in gas wells too. Oh no, I would never publish in a religious journal. And that was his response. I said, oh yeah, you lose your National Science Foundation grant money too.
So you think the Earth is 35,000 years old?
Conventional dating would say that it is, but there's this phenomenon known as accelerated nuclear decay, which was the subject of the radioisotopes in the Age of the Earth book. And when you factor that in, it will drop towards the 6,000 years. So I have not included, my main point was evolutionists say it's millions and billions of years old, and I say no, it's on thousands of years old using their method. And then when you factor in the new things that we're finding in creation science about accelerated nuclear decay, which has been experimentally verified in some instances. That's the neat thing. You say, hey, we're on to something. And so it's generally ignored. I was looking at the air level for xenon. And the big question is, why is all this stuff in the strata greater than the air level if the atmosphere is supposed to be degassed from the mantle? Shouldn't it be that, which is what we find in the mantle, when they're finding values around 7 in the mantle? And why is that? It's the other way around. You know, the xenon 129 in the atmosphere is less. It doesn't fit. And so they go searching off for all kinds of answers. They say, well, the stuff that's in the wells must have come from the mantle. The mantle's very old. So obviously there's been a big loss of xenon in the atmosphere. And they talk about all various theories of losses of gases, over millions and billions of years. Big problem with that is helium. Dr. Humphreys wrote a paper on that, gave the answers. His helium has a very high diffusion rate and all. Measured it, got the results, and said helium diffuses so rapidly that if the Earth was very old, we wouldn't have any left. I mean, it'd be gone. And they say, well, here's lots of it. So it's right in your face. We got to dance around it somehow. So, all right.